So in this video, we're going to look at the quadratic function. Now, any function of the form f of x equals ax squared plus bx plus c, where a, b, and c are numbers, is called a quadratic function. And we should note here that a cannot be 0 or it becomes a linear function, so a straight line. So in this example, we want to sketch the function of x equals x squared plus 2x minus 3, and the domain of values for our function is -4 to 2. So we're going to substitute each of those values, and we're going to use the integer values in that range into our function. So f of -4 is going to give us -4 all squared plus 2 multiplied by -4 and take away 3, which gives us a value of 5. Then f of -3 is going to give us -3 all squared, which is 9, plus 2 times -3, take away 3, gives us a value of 0. F of -2 is going to give us -2 all squared, plus 2 times -2, take away 3, which is going to give us a value of -3. Substituting in f of -1 gives us -1 squared, plus 2 multiplied by -1, take away 3, giving us a value of -4. F of 0 would be our next integer value, and that's going to give us 0 squared plus 2 multiplied by 0, take away 3, equals -3, and that's our y-intercept. For f of 1, we've got 1 squared plus 2 times 1, take away 3, giving us a value of 0. And finally, in our domain, we've got f of 2 equals 2 squared plus 2 multiplied by 2, take away 3, and that gives us a value of 5. And now we want to look and see our coordinate pairs. So we've got -4, 5, -3, 0, -2, -3, -1, -4, we've got 0, -3, 1, 0, and finally 2, 5. And we want to plot these onto our Cartesian grid. So our first point is -4, 5. Then we want to plot on -3, 0, -2, -3, -1, -4, up to 0, -3, 1, 0, and finally 2, 5. And then we want to join them together with a nice smooth parabola curve. And finally, we want to label our curve with f of x equals x squared plus 2x minus 3. Now, there are several key features that we need to know about on a parabola. First of all, the line of symmetry down the center of a parabola, and that's the line x equals -1. We've got our roots, and they're at -3, 0, and 1, 0. And then we've got our y-intercept, which is at 0, -3. Now, because we have a positive x squared quadratic function, we have a minimum turning point, and this is on our line of symmetry, and our minimum turning point is -1, -4. So the key points are that the quadratic function curve is known as a parabola. Our vertical line of symmetry for the function f of x equals x squared plus 2x minus 3 is x equals -1. Our parabola cuts the x-axis at zeros or roots for f of x equals x squared plus 2x minus 3, and the roots are x equals -3 and x equals 1. If x squared is positive, there's a minimum turning point for f of x equals x squared plus 2x minus 3, and it's at -1, -4. And if x squared is negative, then there's a maximum turning point.